here's our 6 lab machine learning, deep learning. And we have two parts in this lab. The first one is AWS SageMaker, and the second one is deep learning AI. In the first part, what we have done is first, set up SageMaker. Second, exploratory data analysis. Third, selection of a suitable machine learning algorithm. Fourth, build machine learning model. And last one is gather results. And the second part is what we did in the second part is first set up EC2 instance, second build deep learning model, and then finally get the result. So let's get into the first part first. What we did is get into the AWS SageMaker console, create an AWS SageMaker notebook instance. In the IAM role field, choose create a new role to help Amazon SageMaker create a role with the required permission and assign it to the instance. In the create an IAM role box, select any S3 bucket. This allows AWS SageMaker instance to access all S3 buckets. And then we have to prepare the data. Choose the open Jupyter and choose conda path3 kernel. Then define IAM role in your Jupyter notebook. After that, we have to create an S3 bucket that will store data we are going to use. And then we have downloaded the data to Amazon SageMaker instance and load it into a data frame. We will show that in a demo in a while. So here's the setup. And about the data analysis, we have to make scatter plots of features of all possible permutations and use different colors to represent class 0 and 1. We have 4 features, so we have 6 kind of permutation. Here's the third one, 4, 5, 6. And about the algorithm we used, we compared logistic regressions, spot vector machines, and Bayes classifiers. Logistic regression is best suited for binary classification, data sets where y equals to 0 or 1, where 1 denotes the default class, for example, in predicting whether an event will occur or not. There are only 2 possibilities. That is occurs, then we denote as 1, or it doesn't occur, then we denote it as 0. So if we were predicting whether a patient was sick, we would label sick patients using the value of 1 in our data set. About the spot vector machines, a spot vector machine is discriminative classifier formally defined by a separating hyperplane. In other words, given labeled training data, the algorithm outputs an optimal hyperplane which categorizes new examples. In 2-dimensional space, this hyperplane is a line dividing a plane in 2 parts, where in each class layer in either side. About Bayes classifier. A Bayes classifier is based on the idea that the role of a class is to predict the value of features for members of that class. Examples are grouped in classes because they have common values for the features. Such classes are often called natural cans. In this section, the target feature corresponds to discrete class, which is not necessarily binary. The idea behind a Bayes classifier is that if an agent knows the class, it can predict the values of the other features. If it doesn't know the class, Bayes' rule can be used to predict the class given the future values. In a Bayesian classifier, the learning agent builds a probabilistic model of the features and use that model to predict the classification of a new example. We decided to choose SVM as the algorithm to use in this problem. It has 4 advantages. First one, effective in high-dimensional spaces. In our lab, we have 4-dimensional data. And the second advantage is still effective in cases where number of dimensions is greater than the number of samples. And third advantage is uses a subset of training points in the decision function, so it's also memory efficient. The fourth one is about versatile. Different kernel functions can be specified for the decision function. Common kernels are provided, but it's also possible to specify custom kernels. In this part, we have to build machine learning model, training and testing data generations. Here's the result we get. And here's the second part, the deep learning AMI. First, we have to open EC2 console. Here's what we did in the lab, so you can check that in the demo we will post later. After we configure the instance, we have to connect to that. And then active TensorFlow with Python3 source. We have to create a Python file, create data file. In that model we have created, generate training and testing data. Use Keras library to build classifier. So here we have 2 layers neural network. The first layer activation function is value with 35 units. Set the dropout layer with p equals to 0.5. And second layer activation function is sigmoid with 1 unit. Choose optimizer to be atom and loss function to be binary cross entropy. Now here's the result we get. First, we have to create a SageMaker instance and set configurations. In this part, we import the data, analyze the data, and make the module to manipulate the data. At the end of the lab, we have to stop the instance and delete the in case for the unnecessary cost. In this part, we create a deep learning instance and set configurations. In the final part, we create the module file and data file and use them to get the final result.